Hello students, here I am going to explain about photoelectric effect. In this experiment, here we are going to calculate Planck's constant value and work function of the given photosensitive metal. To do this experiment, we need apparatus. The main apparatus is Planck's constant apparatus and a vacuum phototube. It is attached with photosensitive metal, and this one is the positive terminal of the photosensitive metal and this one negative terminal of the photosensitive metal. And the light source, filters. To vary the frequency, we are using these filters: orange filter, green filter, red filter and blue filter. Now we need patch cards. Now I will show you the circuit diagram. Based on the circuit diagram, we are going to give the connections. So this is the circuit diagram. Positive terminal of the voltage is connected to negative terminal of the photosensitive metal, and the positive terminal of the photosensitive metal is connected to negative terminal of the microammeter, and the positive terminal of the microammeter is connected to negative terminal of the voltmeter. With the help of this circuit diagram, now we are going to connect the circuit. Take the patch cards. Start with positive terminal of the voltmeter is connected to negative terminal of the photosensitive metal, and the positive terminal of the photosensitive metal is connected to negative terminal of the ammeter, and positive terminal of the ammeter is connected to negative terminal of the voltmeter. Now switch on the light source and switch on the mains. Now here you can see, make this knob minimum. Now we have to give different frequencies by using these filters. First use red filter. Keep that red filter in the given slot. By increasing the voltage, retarding voltage we called, at a particular voltage this becomes 0. The current in the circuit becomes 0. Note down that reading. You have to note down this reading. This voltage we called as stopping potential, so 0.2. Again make it 0 and change the filter. Keep orange filter. Again increase the retarding potential. By increasing this value, this becomes 0. The current in the circuit becomes 0. You can see that one. At a particular voltage, here the current in the circuit becomes 0. You have to note down this voltage value, 0.48, approximately 0.5. Then make it 0 and change the filter. Keep orange filter. Again increase the stopping potential value at a particular potential, approximately at 0.6. Here this becomes 0. Note down this reading and again keep in minimum position. And the last filter is blue one. Keep the blue filter and again increase the value at a particular voltage. this becomes 0. Yeah, you can see approximately at 0.9 the current in the circuit becomes 0. So note down this reading and make it 0. So with this we have completed readings. Now I will show you the readings what we are have here in this. For various frequencies, red, orange, green, blue, these are the frequencies, known values. For those values we have taken the readings 0.3, 0.55, 0.75, 0.94. With the help of these readings, now we have to draw the graph. Now I will show you how to draw the graph. Here, take frequency on x-axis, 1 unit is equal to 1 into 10 to the power of 14 Hertz. On y-axis, take stopping potential value, 1 unit is equal to 0.1 volts. Here you can see. On x-axis, 1 into 10 to the power of 14, commonly I mentioned here into 10 to the power of 14 in Hertz, and stopping potential in volts I mentioned 0.1, 0.2, 0.3 and so on. For different frequencies we have different stopping potential values. First keep the points here on the graph and then draw the graph. That graph cuts the x-axis at some point, and the same graph if you extend it cuts the negative y-axis at some point. Here it cuts the y-axis at minus 1.5. Once this graph completed, take the slope of this line, straight line, with the formula y2 minus 1 by x2 minus x1. Here, so here I considered on x-axis 6 and 5. So with that, it cuts the straight line at 2 points. From there, I drawn two parallel lines which cuts the y-axis at y1 and y2. With the help of these points, here I calculated slope 0.8 minus 0.4 by 6 minus 5 into 10 to the power of 14. With that we have 0.4 into 10 to the power of minus 14. This is the slope. Now, this is the formula which is used to calculate the Planck's constant. Here it is just like a y is equal to mx plus c formula. So with the help of this formula we are going to calculate Planck's constant. So we got this slope 0.4 into 10 to the power of minus 14. So there slope represents h by e. So h by e is equal to 0.4 into 10 to the power of minus 14. After calculation, here we will get h value, Planck's constant value 6.4 into 10 to the power of minus 14 joule second. After that, we will do the calculation for work function. So work function we can calculate by using the following formula. Here y-intercept represents minus w naught by e plus a, that is equal to minus 1.5 volts minus w naught by e. Here this is the contact potential 0.5 given, so that is equal to minus 1.5. Finally we will get w naught work function is equal to 2 volts we are getting. So once you get all these values, write the result. Planck's constant is 6.4 into 10 to the power of minus 34. Work function of the given metal is 2 electron volts, and the threshold voltage here we got 3.9 into 10 to the power of 14 Hertz. I hope this video will help you in your practical examinations. All the best.